We're now starting trig review test 3 problems 6 through 9. Number 6. Find the exact value by using a sum or difference formula of the sine of 255 degrees. Find two angles on the exact value chart whose sum or difference is 255 degrees. You know that if you add 210 plus 45, you're going to get 255. You know that 210 degrees has a related angle of 30. You either think through the steps by using the exact value chart in the coordinate axis, or you look at your unit circle. 210 degrees, we've got the exact value of the sine and cosine of that. We also know the exact value of the sine and cosine of 45. So we've got our numbers that we need to use for this problem. We now look at the identity that we would use for sine of alpha plus beta. Write that formula down. Sine of alpha, cosine of beta, plus cosine of alpha, sine of beta. You just looked at this sheet and found that. Substitute your degrees in place of alpha and beta. Sine of 210 degrees times the cosine of 45 degrees plus the cosine of 210 degrees times the sine of 45 degrees. After you've done that, then you can easily look at the exact value chart. What is the sine of 210 degrees? -1/2. The cosine of 45 degrees is the square root of 2 over 2, plus the cosine of 210 degrees is negative square root of 3 over 2, and the sine of 45 is also the square root of 2 over 2. Simplify, you get negative square root of 2 over 4 minus the square root of 6 over 4. Final answer, negative square root of 2 minus the square root of 6 all over 4. I would love to say you can leave the answer just like that, but the testing software doesn't do that. They factor out a square root of 2 out of the numerator on this. You have negative square root of 2 times 1 plus the square root of 3 all over 4. This is the answer you're going to see in your multiple choice answers. Number 7. Find the cosine of 285 degrees. We're looking for two angles that add or subtract to give us 285 degrees. We want those angles to be angles that we can find on this unit circle. So I see 240 and I see 45. When I add those together, I get 285. So cosine of 240 degrees plus 45 degrees. Then write down my formula for cosine of alpha plus beta. Cosine of alpha plus beta is cosine alpha, cosine of beta, minus sine alpha, sine of beta. Write that down. This is alpha, this is beta. Substitute those values for alpha and beta into this formula as you write it down. So you have cosine of 240 degrees times the cosine of 45 degrees minus the sine of 240 degrees times the sine of 45 degrees. Look at your unit circle. Find these values. Substitute these values in this formula and simplify. The cosine of 240 degrees. Remember, it's cosine comma sine, so this is negative 1/2. Cosine of 45 is the square root of 2 over 2 minus the sine of 240. Here I am at 240. That second number is negative square root of 3 over 2. Be careful with your signs. Sine of 45 is the square root of 2 over 2. Simplify. You get the square root of 2 over 4. Look at all these negative signs. That's going to change. That should be a negative square root of 2 over 4. These two negative signs are going to make this be plus the square root of 6 over 4. I'm going to rewrite this. I'm going to rearrange these and get the square root of 6 over 4 minus the square root of 2 over 4. I just put my positive term first. Square root of 6 minus the square root of 2 all over 4. Do that same little procedure we did on problem number 6. Factor out the square root of 2. You will get the square root of 2 times the square root of 3 minus 1 all over 4. Final answer. This little part right here may bother you a little bit, but if it does, you just look back at these problems on this video a couple of times until you feel comfortable with it. Number 8. Find the exact value of the sine of 20 degrees times the cosine of 40 degrees plus the cosine of 20 degrees times the sine of 40 degrees. When it says find exact value, that means I want the exact value. I do not want a decimal. That's why we use these sum and difference formulas. We look at this expression. We got sine, cosine, plus, cosine, sine. We see which of these sum and difference formulas that expression would fit. And notice that sine of alpha plus beta is sine cosine plus cosine sine. So this is my alpha, this is my beta. This expression is the same as the sine of 20 degrees plus 40 degrees, because it fits this. 20 degrees plus 40 degrees is 60 degrees. The sine of 60 degrees from your exact value chart or either from your unit circle. Here's 60 degrees. The sine is square root of 3 over 2. Final answer. Number 9. The cosine of 7 pi over 18 times the sine of 2 pi over 9 minus the cosine of 2 pi over 9 times the sine of 7 pi over 18. Again, I'm looking to see if I can simplify, if I can first match this up to one of these sum and difference formulas, because I don't know what the cosine of 7 pi over 18 is. 7 pi over 18 doesn't fit any of these exact value things on this unit circle. So I want to do this the easiest way possible. Notice cosine sine minus cosine sine fits the sine of alpha minus beta even though they have them in opposite order, it still fits. Sine of alpha minus beta is sine cosine minus cosine sine. This is my alpha. This is my beta. So I have the sine